Okay, there are a few of you who are struggling with dealing with matrices that have infinitely many solutions. So I thought I'm going to do one more to see if I can kind of clear this up. Now, first things first, I just made up this set of equations off the top of my head. And then I went ahead, because most of you are not struggling with the solving at this point, or at least those of you who are requesting help aren't really struggling with the concept here. You're really struggling with how do I read my answer and how do I interpret it? So what I did, I took this system of equations, I put it into a matrix, just like as we practiced in other problems. Then I did reduce for echelon form in the calculator, because at this point I'm hoping you know how to do the row operators. Now it's more of just a, what do I do with my answers? So I used the calculator to help me out. So let's go through this part very slowly. Now you'll notice, I set my equations up where this is my x's, this is my y's, this is my z's, this is my equal sign. So it would be the same thing here. This would be my x column, y column, z column, equal sign column. Now, as a hint for some of you who are struggling with the whole, or I'm going to get to this in a minute, but struggling with the whole in terms of x or in terms of y, is there any reason x has to be on the left? Is there any rule that says they have to be written in alphabetical order? No, all it says is this column represents all my x's. So if I was going to rearrange my equation somehow, the 3 and the 5 would have to be in the same column. I can't change that, but they don't have to be in the first column. They could be in any column I want them to be in. Okay, so nonetheless, here we go. Now, let's focus in on this. How we read our answers is incredibly important. You just go by row, because remember, these are equations. And this process was elimination technique. This process, all it did was do row operators, or adding and multiplying it by a number and then adding the two of them together to make a new equation. So these are still equations. So this first row here, we're going to interpret these numbers here. So it means we have 1x plus 0 y's. Well, since we have 0 y's, I'm not going to write it. We don't need them. Plus 1/4 z equals 27/8. The next row, once again, has 0 x's. I'm not going to write it, okay? But it does have 1 y, negative 1/16 z, and negative 15/32 equals negative 15/32. So now, if I were to solve each of these equations for one of the variables, it seems easiest to solve this first one for x because it's like a coefficient of 1. So therefore, I would be left with x equals 27/8 minus 1/4 z. And in this bottom row, if I were to solve for y, I would have negative 15/32 plus 1/16 z. So now this problem, how it's written, is easiest to be described as in terms of z. And the reason why is I now have an equation for x in terms of z and y in terms of z. So what am I saying? Our ordered triplet would usually be written like this: x comma y comma z, right? We put in our x value in the first spot, y value in the second spot, z value in the third spot. And when we have problems that have answers, that have an exact answer, one answer, we would get something like this: x equals 4, y equals 3, and z equals 2. So, or whatever the numbers would be. So therefore, you would fill them in: 4, 3, 2. So everywhere I had an x, I replaced it with a 4. Everywhere I had a y, I replaced it with a 3. Everywhere I had a z, I replaced it with a 2. And there's our answer. Okay, this problem, not so simple. But it's not that bad either, because I know everywhere I have an x, I can replace that with 27/8 minus 1/4 z. Everywhere I have a y, I need another color. Let's go with orange. Everywhere I have a y, I can replace it with that. So I'm going to replace it with 15/32 plus 1/16 z. And then finally, for my third part of the ordered triplet, I've already got my x taken care of. I already have my y taken care of. Z is just z, so I leave z alone because z equals z. There's no equation here to change it into z's. It's already z's. So now you can see our answer is written in terms of z, because all of our values, all of our variables have been replaced by something with a z in them. Now, the problem that a lot of you run into is most of the problems don't ask for it in terms of z, they want it in terms of x. Now, you could go through a whole bunch of horrible math to try and solve. So say, all right, I know I have a z, ever have a z, I can replace it with a y, and that would be horrible. Instead, start the whole problem over. Start the whole problem over. And go back to this original set of equations and say, I don't want to write it in this matrix this way. If I do it this way, I end up with my answers in terms of z. Because think about how Gauss-Jordan works. This is one of the reasons I want you to do it by hand, so you understand why we end up in terms of z. We always start with the top left number and get zeros below it. We then go down the diagonal, we'll take the next number and get zeros above it, which means this third column never has a chance, never can become ones and zeros. It's just going to be stuck that way because there's nothing in the diagonal for us to go to. So this is the thinking portion of the class. You got to figure out, how are you going to rearrange this? How are you going to write it? So instead of having z's over here, so when your problem's all done, you end up with things in terms of z, we want things in terms of x. All right, I hope that's enough of a hint. I hope that's enough to get you going. And I hope, hopefully that one more example was all you needed to kind of get you over the hill. Let me know.